The year was 1997. Fishermen in Peru watched helplessly as the ocean turned warm and empty. Coral reefs bleached white across the Pacific. Floods buried entire neighborhoods in California. Wildfires tore through Indonesia, choking skies with smoke for months. Droughts cracked the earth across East Africa, and millions faced famine. All of it traced back to one invisible force in the Pacific Ocean. They called it El Niño. And now scientists are warning us something bigger may be on its way. Not just another El Niño, but a Super El Niño. The kind that doesn't just bend weather patterns, it breaks them. But here's the thing nobody's talking about. It's not just the storms or the droughts or the floods you need to worry about. There's a deeper story, a more dangerous one. And today, we're telling it. Before we get to the super version, we need to understand the original. In the tropical Pacific Ocean, winds blow east to west, pushing warm surface water toward Asia and Australia. This is normal. It keeps the Pacific in balance. The western side stays warm, the eastern side stays cool. But sometimes something shifts. The trade winds weaken. That warm water, instead of piling up in the west, sloshes back toward South America. The eastern Pacific heats up. And when it does, the entire atmosphere above it changes. Weather systems reorganize. Jet streams move. Monsoons fail. Rains fall in the wrong places. Droughts hit where rainfall should be plentiful. This is El Niño. It's not a storm. It's not a hurricane. It's a shift in the ocean's heat. And that shift rewrites weather across the entire planet. The name itself comes from Spanish, the little boy, or more specifically, the Christ child, because Peruvian fishermen noticed the warm water arriving around Christmas, but there's nothing little about what it does. So what makes a Super El Niño different? A regular El Niño raises sea surface temperatures in the central and eastern Pacific by 1 to 2 degrees Celsius above normal. That's enough to cause significant disruption. A strong El Niño pushes that number past 2 degrees. The events of 1982 to 83 and 1997 and 88 fell into this category, and they caused catastrophic damage around the world. A Super El Niño? We're potentially talking about temperature anomalies of 3 degrees or more. Sustained, widespread, happening in a world that's already warmer than it was 50 years ago. And that last part is the key detail that almost nobody is discussing. Climate change has already raised the baseline temperature of the oceans. The Pacific is warmer now than at any point and on top of that already elevated baseline, the effects don't just add up, they multiply. Think of it like this. If you pour hot coffee into a cup that's already warm, it stays hot longer. The ocean is the cup, and right now, the cup is very, very warm. Climate scientists use sophisticated computer models, simulations that track ocean temperatures, wind patterns, atmospheric pressure, and dozens of other variables to predict El Niño events. And in recent years, those models have been sending warnings. After a rare triple-dip La Niña, 3 consecutive years of the cool phase, the Pacific has been charging up. Enormous amounts of heat have been building beneath the surface. And when that heat finally releases, it won't come quietly. The Coupled Model Intercomparison Project, one of the most comprehensive climate modeling efforts in history, has flagged increased probability of extreme El Niño events in the coming decades. Multiple independent research teams have reached similar conclusions. One landmark study in the journal Nature Climate Change found that climate change doubles the frequency of extreme El Niño events. Events that once occurred roughly every 20 years could start appearing every 10. Let that sink in. The disaster-level El Niño of 1997 was supposed to be a once-in-a-generation event. In the future we are building, it could become routine. You've probably heard the standard list: more hurricanes, heavier rainfall, flooding, drought. But the true impact of a Super El Niño goes far deeper, into systems we rarely think about until they collapse. Let's start with food. El Niño disrupts agriculture across multiple continents simultaneously. Australia faces drought. Southeast Asia sees crop failures. East Africa experiences delayed or failed rains. South America, particularly Brazil and Colombia, faces extreme weather that damages coffee, soy, and sugarcane harvests. These aren't just statistics. These are food prices. Your grocery bill. The cost of the basics that billions of people depend on. In 1997 to 98, the strong El Niño contributed to food crises that affected tens of millions of people in developing nations. A Super El Niño, amplified by a warmer planet, could push those numbers far higher. Then there's water. El Niño disrupts the hydrological cycle, the system by which fresh water moves through the atmosphere, falls as rain or snow, and replenishes rivers, lakes, and aquifers. When that cycle breaks down, it isn't just inconvenient. It's existential. Cities like Lima, Peru, depend almost entirely on glacial meltwater for their freshwater supply. Those glaciers are already shrinking due to climate change. An extreme El Niño event that alters precipitation patterns could push vulnerable regions into permanent water scarcity. And then, the coral reefs. Coral bleaching events are strongly correlated with El Niño. Warm water stresses coral polyps, causing them to expel the algae that give them color and nutrition. If temperatures stay elevated long enough, the coral dies. The Great Barrier Reef, the largest living structure on Earth, has already experienced mass bleaching events. A Super El Niño could push large sections of the world's coral reefs past the point of recovery. And coral reefs support roughly 25% of all marine species. Lose the reefs, and you begin to lose the ocean. Here's the part that almost never makes the headlines. El Niño doesn't just cause weather disasters, it causes political instability. Research published in the journal Nature found a striking correlation between El Niño events and the outbreak of civil conflicts around the world. In the years following a strong El Niño, the probability of conflict in tropical countries, particularly those dependent on rain-fed agriculture, roughly doubles. The mechanism is brutal in its simplicity. Drought destroys crops. Crops failing means food shortages. Food shortages mean rising prices, hunger, and desperation. Desperate populations become unstable. Unstable regions become conflict zones. We saw this pattern play out after the 2009-10 El Niño contributed to drought conditions across the Middle East and North Africa. Poor harvests, rising food prices, economic stress. These were among the underlying conditions that sparked the Arab Spring. A Super El Niño wouldn't just affect one region. It would send shockwaves through dozens of countries simultaneously. Refugee flows, border tensions, resource conflicts, and governance crises, all compounding each other at the same time. The world's military planners and intelligence agencies already classify climate disruption as a major security threat. A Super El Niño would be a live fire test of that threat, all at once, globally. Let's talk money. The 1997 to 98 El Niño cost the global economy an estimated $45 billion in damages. Adjusted for today's values and today's more interconnected global supply chains, a comparable event would cost far more. A Super El Niño would not be comparable. It would be categorically worse. Insurance companies have already started pricing this reality into their models. In high-risk regions, Australia, parts of Southeast Asia, coastal areas of Latin America, property insurance is becoming unaffordable or unavailable entirely. This is not a distant future problem. It is happening now. The financial sector has a term for it: physical climate risk, the direct economic damage from extreme weather events, and the major financial institutions, from the IMF to the World Bank to major central banks, are now treating it as a systemic risk to the global financial system. Translation: a Super El Niño doesn't just damage homes and crops. It could damage economies, entire economies, possibly simultaneously. The good news, and there is good news, is that we have warning systems that didn't exist before. The TAO Triton Array is a network of moored buoys spread across the tropical Pacific, continuously monitoring sea surface temperatures, wind speeds, and ocean heat content. This data feeds climate models in real time. NOAA's Climate Prediction Center issues regular El Niño advisories. The World Meteorological Organization coordinates international monitoring efforts. Satellite systems track cloud patterns and sea surface temperatures from space. In 1997, the strong El Niño caught much of the world by surprise. Today, we would have months of warning before a major event reached its peak. But warning is not the same as preparation. The most vulnerable communities, farmers in East Africa, coastal settlements in the Pacific Islands, densely populated river deltas in South Asia, often lack the resources to act on warnings even when they receive them. A 6-month lead time means very little if you don't have the infrastructure, the finances, or the government support to actually change course. And there is a deeper limit to the warning systems. They can tell us El Niño is coming. They are becoming better at predicting its strength. But they cannot fully predict the cascading, interconnected failures that follow. The crop shortfalls that lead to price spikes that lead to unrest, that destabilizes governments, that stops climate adaptation funding. The chain of consequences is too complex, too human, and too deeply tangled to model perfectly. So what's the answer? Experts, climate scientists, disaster risk specialists, economists, and security analysts broadly agree on several priorities. First, early warning must reach the last mile. It's not enough for governments and international agencies to know a Super El Niño is coming. That information must reach the village farmer in Ethiopia, the fishing community in Indonesia, the smallholder in Peru. Early warning systems need investment, not just in the technology, but in the human networks that translate scientific data into local action. Second, infrastructure must be built for the climate we're heading into, not the climate of the past. That means flood defenses designed for heavier rainfall, agricultural systems diversified to handle drought, water storage expanded in regions that will face increased scarcity. Third, the financial architecture for disaster response needs to be rebuilt. The current system, where poor countries get hit hardest, then wait years for international aid that arrives too late, is not fit for purpose in a world of intensifying El Niño events. Faster, prearranged funding mechanisms, better insurance access for vulnerable nations, debt relief that allows affected countries to invest in resilience rather than spend recovery funds on debt payments. Fourth, climate change must be addressed at its root. Every fraction of a degree of global warming we avoid is a fraction of a degree less amplification of the next El Niño. The long game of emissions? Reduction in clean energy transition is not separate from disaster preparedness. It is disaster preparedness. Let's zoom out. El Niño has always existed. It is a natural feature of the Earth's climate system, cycling through warm and cool phases over years and decades. Before human civilization, it caused droughts and floods. It disrupted ecosystems. It reshaped coastlines. But we are living in a different era now. We have taken a natural system, one already capable of enormous disruption, and turned up the dial. Every molecule of carbon dioxide we add to the atmosphere is stored energy. Every degree the ocean warms is potential that will eventually be released. We are, in a very real sense, loading the climate system like a spring, coiling it tighter and tighter. And the next strong El Niño is what happens when it releases. The 1997 El Niño killed an estimated 23,000 people and cost the world nearly $50 billion. It was one of the most impactful climate events of the 20th century. A Super El Niño. In today's hotter world, with today's crowded coastal cities, today's strained food systems, today's volatile geopolitical landscape, could be something else entirely. It wouldn't just be a weather event. It would be a civilizational stress test. We don't say this to frighten you. We say it because the first step toward surviving a serious threat is taking it seriously. The scientists who study El Niño are not alarmists. They are methodical, careful, conservative people who deal in probabilities and data. And the probabilities and data are telling them something important. Something is building. In the Pacific Ocean, right now, heat is accumulating beneath the surface. The atmosphere above is responding. The models are watching. Whether the next El Niño becomes a Super El Niño, and exactly when it arrives, nobody can say with certainty. That's not how climate science works, but the direction of travel is clear. The conditions that make extreme El Niño events more likely are already in place. They are deepening every year, and the world, by and large, is still not ready. So now you know what no one was telling you. What you do with that knowledge is up to you.